Welcome back to Geology Dean's Igneous Rocks mini-series. In today's episode, number 5, we're diving deep into the mineralogy of igneous rocks. What exactly are these rocks made of? And how do those ingredients come together? Let's find out! Imagine a magma chamber, a hot pot of molten rock beneath the Earth's surface. As this magma begins to cool, it doesn't just solidify all at once. Instead, minerals start to form in a specific, predictable order. This amazing process is known as crystallization sequence. Think of it like making rock candy, where sugar crystals form out of a solution as it cools, but on a much grander, hotter scale. The key factor controlling which mineral forms first is temperature. At the highest temperatures, we get what are called mafic minerals. These minerals are rich in magnesium and iron, which gives them their characteristic dark colors. The first to crystallize is often a beautiful green mineral called olivine. As the magma cools further, pyroxene, another dark-colored mineral, begins to form. These are the building blocks of mafic rocks like basalt and gabbro. Now, as the temperature continues to drop, the composition of the remaining liquid magma changes. It becomes depleted in iron and magnesium and enriched in other elements like silicon, aluminum, sodium, and potassium. This is where the next group of minerals, the felsic minerals, comes into play. Felsic is a term derived from feldspar and silica. First, in the lower temperature sequence, we often see amphibole and biotite mica crystallizing. Amphibole is typically dark, but it forms at a lower temperature than pyroxene. Biotite is that flaky, black mica you can often peel apart with your fingernail. Following these, the feldspar family begins to dominate. There are two main types, plagioclase feldspar, which can range from calcium-rich to sodium-rich, and potassium feldspar, which is often pinkish in color. Finally, at the lowest crystallization temperatures, if there's any silica left over, quartz will form. Quartz is pure silicon dioxide and is one of the most common minerals on Earth's surface. It's glassy hard and often fills in the remaining gaps between the other minerals that formed earlier. So, when you see a rock like granite with its specks of black biotite, pink potassium feldspar, and glassy grey quartz, you're looking at a rock that represents the final stages of magma crystallization. So, to recap, igneous mineralogy follows a predictable path governed by temperature. High temperatures give us dark, mafic minerals like olivine and pyroxene. As the magma cools, we transition through amphibole and biotite, then into the lighter-colored felsic minerals like feldspar and finally quartz. This predictable order is a fundamental concept in geology and helps us understand the story behind every single igneous rock we find. Thanks for joining me for this episode on igneous mineralogy. Be sure to subscribe